Alrighty, guys. So we're going to talk up the Unit 3 review because we're now at the end of our unit. So we're going to look at our sequences and we're going to go back and look at our functions. On Delta Math, I have 11 different topics, 2 questions a topic, so 22 questions total. I want to help you with one of each. So this video might be a little long, but you'll see an example of one of each, and then hopefully that'll be enough for you to get through this unit review, which will prepare you for the Unit 3 test. Before we get started, I just want to share with you this visual because it basically sums up our 4 formulas for the arithmetic and geometric sequences. And it does so in a way that I think will really highlight its similarities and differences to help you connect which one is which. For example, if we're looking at the columns, it splits it down by arithmetic sequences and then the geometric sequences. Remember, arithmetic is when we're adding or subtracting. Geometric is when we're multiplying or dividing to get to the next term. Now, if we look at the rows, it breaks it down by the type of formula. It breaks it down by the explicit formula versus the recursive formula. And this is where it really highlights the similarities and differences between both. For example, if you're looking at the explicit formulas between the two types, you'll see they both have A1. You'll see they both have N minus 1. And then they have their own respective common, either the common difference for arithmetic or the common ratio for geometric. And notice the differences. We are multiplying by our common difference with n minus 1 versus exponent for the common ratio to the n minus 1 power. The reason is how the pattern is moving. If I am adding or subtracting, repeated addition or subtraction is simply multiplication. If I am multiplying each time, if I'm geometric, the repeated multiplication is simply exponents. And then if I'm adding for arithmetic, I add the first term. If I'm multiplying for geometric, I multiply by the first term. So they're actually very similar. It's just dependent on their pattern. If I'm adding versus if I'm multiplying. And then, guys, look at the recursive formula. This one's even closer together than the explicit formulas were because the whole first part is exactly the same. A1 is whatever our first term is. And then an equals an minus 1, either plus the common difference or times the common ratio. Hopefully this made a little more sense, guys, looking at our 4 formulas for the 2 different types of sequences. Let's use them in our Delta Math Unit 3 review. So let's start off here with the geometric sequence, nth term of a geometric sequence. This is probably the toughest one here, guys. But what we need to do first is we need to find that common ratio. So what I'm going to do, if I can't see the pattern right away, all I'm going to do is take the second and divide it by the first. So I have negative 18 divided by positive 9. 18 divided by 9 makes 2. Negative divided by positive makes negative. So my common ratio is negative 2. Now I could use that and my A1 value and my N value to plug it into my formula and then simplify. So I have A1 times my common ratio raised to the N minus 1 power. Now some of these we could simplify really quickly. I have negative 2 or 12 minus 1. Okay, so I want 9 times negative 2 raised to the 11th power. From here, guys, you better use a calculator. So if we're using a calculator, we want negative 2 raised to the 11th power, which gets me negative 2,048. My last step is times that by 9, so negative 2,048 times 9 gets me negative 18,432. There we go. There we go. So there we go. So we've got our answer for this one here using our explicit formula. So that's one of them. Let's try another one here. Looking at our recursive formulas, remembering that it's just A1 There we go. So now let's jump to our recursive formulas, knowing that it's just A1 equals first term, AN equals whatever our pattern is with AN minus 1. So if I'm looking at this one here, I have A1 is equal to 5, AN is equal to times 4 AN minus 1, and we want the sixth number. So let's come up with our list. My first number was 5. Then I go to the next number, and the pattern I use is given right here next to the AN minus 1. If it's in front, that means multiplication. If it's behind, then that's either the adding or subtract. And we don't worry so much about this minus 1 there. That's just our place filler. That's just telling us where we are in the list. So this big 4 is the operation I want to use, so I'm just timesing everything by 4. 5 times 4 makes 20. 20 times 4 makes 80. 80 times 4 makes 320. Ooh, 320 times 4? Oh, I can't do that in my head. Let's use a calculator. I get 1280. That's 1, 2, 3, 4, 5 numbers, but remember, I needed 6. So let's do this one more time. 1280 times 4 gets me 5120, 5,120. There's our 6 terms. So now I can get rid of the rest of these by simply erasing. Submit this answer and call it a day. Going on to our next one, back to our arithmetic sequences here, guys. We're looking for the nth term of this arithmetic sequence, and this time they're looking pretty far away. We're looking at the 97th term of this one. We're going to do it very similar to what we did with the geometric sequences, but instead of finding common ratio first, we need to find that common difference. To find it, subtract. I have negative 23 minus negative 5. Recognize the double negative just becomes double positive. So now I have negative 23 plus positive 5, which makes a common difference of negative 18. So now we can plug that into our formula using A1, using our common difference, and using the n value. I have A1 plus the n value minus 1 times my common ratio, common difference of negative 18. 97 minus 1 makes 96. 96 times negative 18. Ooh, what does that make? Negative 1,728. Then we want to add the negative 5 to it, and that will get us our final answer. Don't forget about that A1 value. That's what got some of us when we first started this thing here. But if I add that, that simply makes negative 1733. Right? Right. All right, so there's this one, dealing with our formula for explicit arithmetic sequences. Now let's focus on those sequences, guys. If we're looking at our common difference and ratios here. So focusing on this problem, we have -9, -7, -5. It says find the common difference of arithmetic. So that means we're either adding or subtracting to get to the next number. Now, if you can't see it right away, all you have to do is just take the second number, subtract it from the first. So I have -7 minus -9, which makes +2. I'm adding 2 every time in this problem. If you're given a geometric one, this is arithmetic again, but if you're given geometric, just to find it, you take the second one and divide it from the first one. So there's that. Looking at our next one where we had to distinguish between them, this is where we had to check the three different problems, or the three different numbers, and make sure it was the same pattern every time. If I'm looking at this one, 12 minus 3 makes 9. 12 plus 9, not 48. So it's not going to be arithmetic, which means it must be geometric. And you could check it just as easy, guys. Just subtract them and see if I add that number, if it gets me the third. If not, it's geometric. If it does, it's arithmetic. It follows that same pattern. So now we know that it's geometric. This means we must be multiplying by something to get to the next number. So simply divide. What's 12 divided by 3? Well, that's 4. So my common ratio is 4. So there's our sequences. Now let's focus on some of our functions. This is the stuff we did before break. So we really got to bring this thing home. But looking at this one, guys, you're just going to take what's inside our parentheses and plug it in whenever you see the variable. So I have 0, so I plug it in for x, which means I have -3 times 0, which is 0. 0 minus 4 makes it -4. I'm sorry if I'm going too fast, but it is a video, so you could pause whenever and try to clarify and rewatch and all sorts of stuff like that. But there's evaluating. Now, we didn't just evaluate. We also found the input given the output. So if it's not in our parentheses, what did we have to do? We had to set this equal to what our function was equal to. So right now, we're going to set up an equation. I have -5x minus 4 equals the number they give to us, which in this case is a +1. And then I'm solving this equation. So get rid of that -4 by adding, which means I have -5x equals 1 plus 4, which equals 5. And then get rid of that times -5 by dividing. 5 divided by -5 gives us our answer of -1. Okay, so here's a quick little visual of what we did, just in case it was too messy with how I wrote it up, but just set it equal to our output, solve for the input, you get your answer. So that's part of it, but then we also looked at it with graphs. So if we were given a function on a graph, could we find out what the values were? It's the same thing as our equations. We're just using our x and our y, remembering that the input is x and the output is y. So we have an input, which is 2. So let's go to 2 and go download the graph. And what's the y value of this point? Well, 2 hits this graph at -3. So my answer here is -3. And this is a visual I really like because notice it has the arrow from 2 dropping down to the graph and then going straight across to the y value, so that way we could get our output. Very nice. Next, we had determining if they were functions or not. And actually, next we had determining if they were functions or not. And actually, this was even easier because all you had to do when given the graph is the vertical line test. If your graph hits a vertical line more than once at any spot, it's not a function. So this one is a function. And let me show you, this is like my favorite delta math part. Look at this vertical line go across, and notice it only hits our graph at one point every single time. Once. Means we got a function. Only a couple more here, guys, looking at our next one. Looking at our next one, we've got this here. We're looking for which one does not represent a function. Remember, functions have no repeating x values. So if I want the one that does not represent, I want the one with repeating x values. 1, -6, 3, -6, -6, -6 repeats. We only had to check one. That was nice. Not a function repeats. Functions do not repeat. And then our last one, guys, looking at it from a graph. So we had these points here. And we just needed to find the value of whatever point was given to us. We have the input. We have the x value of 2. So let's go to our 2. Notice that it's the point D. Call it a day. Hopefully that clarified some stuff for you guys. If not, feel free to email me. We're also going to talk it up in our class for the unit review, and then we can make it clear before we take that test in the next couple days. Thanks so much. We'll talk to you guys later.